Hello, my name's Hilary Papworth and I lead the ornamental crop research here at NIAB in Cambridge. Here we are at our headquarters site and our glasshouse facility that you can see behind us. Myself and my colleague Benjamin T have been working on an AHDB funded project looking at nutrient management in bedding crops. One aspect of this work has been looking at nutrition delivery using different irrigation systems in different growing medias and different crops. The aim of our experimental work has been to look at the interactions of these different variables under different seasonal conditions. We have looked at two different types of bedding crop as our test species: spring-grown petunia in 1 litre pots and autumn-grown pansy in 12-cell module packs. Both of these crops have different nutritional requirements, and the different growing season will impact on their use of water and feed. We grew each of these crops in 3 different peat-reduced growing media mixes so that we can understand the difference in the different components. These were mixes of peat and perlite, peat and coir, and peat and wood fibre. Each mix was in a 70-30 ratio. Each of these mixes were randomly arranged on benches under 3 different irrigation regimes. These were capillary matting with water delivered by trickle tape, overhead irrigation, which was manually applied to the trial, and an ebb and flood irrigation system. In all cases, the number of irrigation events and the volume of water applied was determined by the needs of the plants. Liquid feed was applied using a dosatron D3 injector via each of the irrigation systems. This was from 1 week after potting. To fully understand the impact of the delivery of liquid feed, we did not use a base feed in our growing media mixes, so all of the feed came in the form of the liquid feed. No recycling of irrigation water took place, but the runoff from the benches was measured and monitored for EC and pH. Monitoring of the nutrient level of the growing media and the irrigation was a key part of this study. We monitored the growing media using saturated media extraction technique and a simple pH and EC meter. For the growing media, this was done on the same day of each week and always before we applied any feed. This ensured consistency and good understanding of what nutrient remained in the growing media. In summer, where water use was high, we found that our ebb and flood irrigation system produced plants with the highest fresh weight in all of the growing media mixes. The capillary matting and trickle tape system produced the smallest plants. Plants growing using overhead irrigation were slightly smaller in size than the ebb and flood system, but the visual quality was as good. In the autumn-grown pansy trial, plants grown on the capillary matting system were very small and of poor quality, with signs of nutrient deficiency. The plants grown with the ebb and flood irrigation or the overhead irrigation were similar in size to each other, and none of these showed any nutrient deficiency symptoms. This work was repeated over 2 years, and we found that the irrigation system that performed most consistently was the overhead one, and this produced the largest plants overall. The use of overhead irrigation allowed us to apply the water in a more responsive way, adjusting the frequency and the volume of water to the plant use. This meant that the feed was being applied in small amounts but on a frequent basis. In the ebb and flood system, when water use was high, the irrigation was also regular and therefore so was the feed. But if the water use was low, the feed was only supplied on an infrequent basis. This is also the same where capillary matting was used, but in this case the difference in results we saw was more extreme. The difference in performance between capillary matting and the other systems was less significant in summer, but the difference in autumn was much greater when the water use was low. In the second year of autumn trials, we looked at using different strategies to improve feed delivery on capillary matting. This was by altering feed dilution rates in response to growing media sampling results, and the use of controlled release fertilizers to break the link between feed and irrigation. In the second year, we repeated our standard feed treatment and also included a feed regime where we adjusted the dilution rate based on the monitoring of the growing media EC. This resulted in adjusting the dilution rate from 1 in 200 to 1 in 100 when our EC readings were lower than desired. This gave a significant increase in the overall plant weight. The inclusion of a controlled release fertilizer to the growing media broke the link with the requirements for water. And in a trial where there was very low water use, This combination produced the heaviest plants overall. Use of overhead irrigation had an impact on the pH of the growing media. The graph in this slide shows that the pH of the growing media increases over time with the use of overhead irrigation. This does not happen with the other two systems. This increase resulted in nutritional deficiency due to high pH being seen in the trial. This increase in pH was the case in all three of the peat-reduced growing media mixes we used in the trial. In terms of the interaction of the irrigation system and the growing media mix, not all components gave the same results. Growing media mixes containing either perlite or coir gave plants with the greatest fresh weights, but this did vary with water use and the irrigation system. Under all irrigation systems, crops and growing seasons, the plants with the lowest fresh weights were from the wood fibre growing media mixes. Our mixes had no base feed in them, so this effect will be compensated for in a commercial growing media mix. But it is important to be aware of the higher nutrient requirement for plants grown in mixes high in wood fibre. So the key findings from this work are that nutrition delivered via overhead irrigation can be effective as doubling the feed concentration delivered by other methods of irrigation, but that the EC of the growing media may appear low in comparison to other irrigation methods. Overhead irrigation delivery of liquid feed gives more consistent results over different seasons than feed delivered by other irrigation methods tested in this trial, but did result in increasing growing media pH in all of our crops and all growing media mixes. Issues of under or overfeeding in systems which rely on capillary matting can be mitigated by altering feed to water ratios, but monitoring EC is essential. Use of controlled release fertilizers allow the link between water use and irrigation to be broken and can be beneficial in periods of low water use. The full details of our experimental work and our conclusions can be found in the AHDB annual reports for the project POBOF 003. We would like to thank the AHDB for the funding of this project and to our industrial collaborators, ICL and OMEX, for their support and contribution to these projects.